Hi, and welcome to my channel. In previous video, we have learnt the basic parts of Arduino Uno board, and write a code to blink LED using Tinkercad online simulation tool and, interestingly, without any physical hardware. In today's video, we will learn how can we interface buttons with Arduino Uno and we'll do different interesting coding examples. It's the most basic part to learn Arduino coding, as in real world, we have to interface many input devices with Arduino. For example, different sensors, keypad, touchscreens, encoders, potentiometers, etc. So learn to interface buttons will help you to easily interface other input devices with Arduino. Let's get started. A push button is a simple mechanical switch that is used to temporarily make or break a connection in an electric circuit when pressed. It's one of the most common input devices used in electronics and embedded systems for user interaction. It consists of two pairs which are mechanically isolated. Pin number 1 and 2 forms first pair while pin number 3 and 4 forms second pair. Remember that pin number 1 and 2 are internally connected, and similarly, pin number 3 and 4 are also internally connected, so we can use any pin from pair. So when user pressed or release the push button, both pairs connect or disconnect with each other respectively, hence providing on or off control to the device. In Tinkercad, the button has pin numbering like pair 1 has 1A and 1B contacts, while pair 2 has 2A and 2B contacts. If you look carefully, you'll get to know that button is available between 1A and 2A contacts and 1B and 2B contacts. Let's make a program to turn on the LED with push button to understand how it works. Before moving towards coding, it is very important to make schematic diagram to clarify how each component will be connect with each other. For this, I am using Proteus Professional software. Open the Proteus software and create schematic. Search Arduino, resistor, push button, and LED in components and place in workspace. Let's suppose we are using digital pin number 8 of Arduino for LED, and pin 9 for push button. Here, the role of resistor R1 is to protect LED from overvoltages, and resistor R2 is pull-down resistor. I will make another video to explain the significance of pull-up and pull-down terminologies, as it is very important concept in the context of embedded system design and programming. So our schematic is ready. Let's build circuit in Tinkercad simulation tool with the help of this schematic. Open the Tinkercad workspace. If you are a new viewer, please watch my previous video for this. Now place Arduino Uno and small breadboard in workspace. Also, place 2 resistors, a push button, and LED as per schematic diagram. Provide plus 5 volts and ground to breadboard from Arduino. Place LED with its protection resistor. Set value of resistor to 330 ohms. Connect LED cathode with ground and resistor with digital pin number 8. Now place push button on breadboard. Note it carefully the place of push button. Do not place on such area of breadboard, where button contacts are shorted by breadboard's internal connections. The push button is connected with pull-down resistor, like shown in the picture. Now connect pin 9 of Arduino with a common point between push button and pull-down resistor. Now our circuit is completed. Let's write code for this. First, write short description about code. It's a good practice. As the code is to control LED with push button, we may write like push button with LED. Turn on LED when the button is pressed and turn off it when the button is released. Write the 2 primary functions which will be common for each Arduino code. A good coding idea is to define elements with pin assigned at the top of functions. It will make your code more easy to understand. Define LED at pin number 8 and button at pin 9. Now, we will use components name instead of pins throughout the code. Now set pin direction as input or output pin. As the LED is output device, we will set LED pin as output pin, while push button as input pin. Let's take a variable with unsigned character type, and it can store value from 0 to 255 as its 8-bit. This variable will store the current status of push button, either it is pressed or not. Read status of push button with digital read function and store it in temp variable. If the button is pressed, temp will store high, otherwise it stores low. We have applied the condition that if the button is pressed, turn on the LED, and if button is release, turn off the LED. LED will be turned on or off using digital write function. Comment out the code to remember its functionality. Let's simulate the circuit, and you can see that, when I press the button, LED turns on, and when I release push button, LED turns off. Thank you for watching. Stay tuned for more upcoming videos.